Okay, welcome back to Number Sense Academy. And today we're going to be talking about finding the equation of a line. So, the equation, finding the equation of a line. So, if you're working with linear equations, you're probably going to be asked to graph a line or do some other work with lines. But sometimes they could ask you to find the equation of a line. So if you're asked to graph a line, you might be given an equation in standard form or in slope intercept form. And then you could use that information to graph the line, maybe come up with a table of values, use the slope and intercept, or just find the x and y intercepts and then connect those dots and then you get your line. The counter to that is they might give you a set of information and say, okay, produce the equation. For example, they could give you 2 points and say produce the equation. Remember, you only need 2 points to be able to graph the line, so you technically only need 2 points to find the equation of the line. Or they might tell you that the equation has some properties or relationship to another line. And then you now have to go in and figure out what information you need from what they've given you to be able to come up with the equation of this particular line. So the goal here is going to provide a lot of examples, but before we get to the examples, we need to make sure that we have some strong background information. So if you're going to be successful at finding the equation of a line, there's some things that you have to know. And the first thing that I would recommend is to ensure that you're comfortable with the standard form of a line or the general form. Remember, the general form is just ax plus by plus c equals 0, where a, b, and c are constants. They could be real numbers. Okay, they can't be variables because if they're variables, then this is no longer a linear equation. So a, b, and c have to be constants. All right, so that's number one. The second thing that you got to be comfortable with is you must know the slope intercept form. All right, and remember that's y equals mx plus b. You need to know what b is and what m is. And and then the relationship between these two, you need to be able to, or inherently, you got to be able to convert general form to slope intercept form. Okay, you got to be comfortable with that. All right. Another thing is that you should be comfortable with is the point slope form. And remember that is y minus y1 is equal to mx minus x1, where x1 and y1 is a point on the line. Okay, and this equation is really useful for actually coming up with your equation. Okay, especially if you have a point, it's useful for finding the equation if given a point, the point being on the line and the slope. Okay, and we'll get into this because the only thing that will be missing, you just need x1, you need y1, and you need m. Okay, so you need this, this, and this. We're not touching this y and this x. because those need to be part of your final equation. All right. So once you have those, then you're pretty good for solving the equation. So you're pretty good with this. Now, to the point of using point slope form to find the equation, you can use y equals mx plus b to find the equation, but you need m and b. Okay? So whereas with point slope form, you need any point, but with y equals mx plus b, you need to make sure that you have the y-intercept and the slope. So that should be my fourth point that you should probably get. Maybe it's not a fourth point, but to kind of tie everything together, make sure you're comfortable with those three forms, because if you have an equation in general form, you have to be able to convert it to slope-intercept form. If you have an equation in slope-intercept form, you need to be able to convert it back to general form, and then point slope form helps you find the equation. So sometimes the question will be find the equation of the line and then put it in standard form. Or they'll say, here's an equation in standard form, find the equation of a line, and then write your answer maybe in slope-intercept form, or put it back in general form. So you have to be very fluid in going back and forth between those forms. Okay, let's keep this going. So another important piece that we should jump in with is calculating the slope, m. So how do we find the slope, m? Given two coordinates or points, x1, y1, and x2, y2, we can find the slope by taking m is equal to y2 minus y1 divided by x2 minus x1. Okay, so these are 2 points. Before, I'm going to say this now in case I forget, you have to be clear in what you're labeling x1 and y1 and x2 and y2. I've seen this done. Do not do this. Like, say if you have 0 and 3, and your second point is 2 and 5, and you say that this is x1. If this is x1, this is y1, which means this is x2 and y2. So before I actually get into a little more details, so from the equation, what I'm saying is 5 minus 2 over 2. Sorry, not 5 minus 2. Let's see. I made the mistake, so it's very possible. 5 minus 3 over 2 minus 0. Do not just pick and choose what you feel like. You can't pick, we're going to say we're going to make 2x1, right? And then we're going to go 2 minus 0. Sorry, no. I'm confusing myself. So you're not going to go 5 minus 3 over 0 minus 2. These are not equal. As you can already see, here you end up with 2 over 2, and in the bottom you end up with 2 over negative 2. These are not the same. These slopes are going in different directions. So do not do this. Be very clear that you get your labeling correct. All right. Now let's get back to this. So if I put this on a graph, y, x. So remember, m equals y2 minus y1 over x2 minus x1. We know that this is the rise over run. Okay? So I'm going to pick two arbitrary points. So let's pick this point here on the y-axis and just this point sitting out here. Okay, so if I connect these two, there's my line, and this equation. I know this is my run, right? And then this is my rise. Okay, so the part that I'm interested in, the slope, is actually the diagonal part. That's what I'm interested in. So I want to find the difference or the ratio of the rise to the run. Because I'm dealing with 2 points, the x values tell me the distance in the direction of x, right? This is in the direction of x. And then the y values, these go in the direction of y. So I need to know the difference in the direction of x compared to the difference in the direction of y, or the other way around. I need to know the difference in the direction of y compared to the difference in the direction of x. And that's why we write it like this. So these are my, my y, x2, y2, and then down here I have my x1, y1. Okay, this is not a product, so let me put a comma there. Differentiate. All right. So I want to know the difference between these two, and I write it as this ratio. So that's how you find the slope of two lines. So let me so I did do the calculation over here, and it's pretty straightforward. Okay, so this is not the right way. So let's get that off of our mind. So do not do it like that. This is wrong. But if I do it this way, I end up with a slope of 2 over 2 is just equal to 1. That's it. Very simple calculation. Just make sure you get the order correct. All right. So that's when you're given 2 points. So, and then I already showed you the point slope form. We know y equals mx plus b. Okay, let's keep this rolling. So oftentimes the equations or the questions will tell us that the equation that we're trying to find has some relation to some other value. So the equation that we're trying to find has some relation or similar properties to other lines. Okay, so you might see something as 1, they have the same y-intercept. Okay, or they have a point in common. So if they have a point in common, that means if it's 2 lines and they have a point in common, so they intersect. They intersect at a certain point. So that means that point is on both of those lines. Or they could say something like, they have too much writing. Same slope. All right. So if I say one equation has the same slope as another line, then I just take the slope value and I'll use it for my new equation. Very possible. Or we could say, so if they intersect at a certain point, this could mean a couple things. So I'll expand on that. So they intersect, but are not perpendicular. So that means they are skewed. All right. And what does this mean that they intersect but they're not perpendicular? Well, let me write the next one first. They intersect, or they are perpendicular. Okay, so let's differentiate between these two. So if I have two lines that intersect, so I have line 1 going this way and then line 2 going that way. This is my L1, L2. So we see where they cross. They cross right here in this middle. So this point is on both of these lines. Okay, so they intersect, but they're not perpendicular. The other thing is that they're actually going in, they're both positively sloped lines, except one has a sharper slope than the other one. So L2 has a sharper slope. So L1 has a sharper slope than L2. But they meet at whatever this point is. Okay? So these are not perpendicular. If they are perpendicular, then they might look something like this. And L3 is perpendicular to L4, which we write as L3 is perpendicular to L4. And what's happening is that they meet at a 90-degree angle. So if we will go back to the basics, X and Y are perpendicular. They meet at a 90-degree angle. So now we have two lines that are in the Cartesian space that are not X and Y, and they are also perpendicular. And this is infinitely possible. You can have many lines out in this space that are perpendicular to each other. Okay? And I'm going to dive into this a bit further. The other point that I'm going to say before I dive into the perpendicular part is that the lines are parallel. Okay, the lines are parallel. So I'm going to grab two things I want to focus on, and we're going to look at what happens when lines are perpendicular and what happens when lines are parallel. So let's jump into that. So let's start with parallel lines. Parallel lines. I'm going to give you some properties of parallel lines. One, parallel lines never, ever intersect. Okay? They have the same direction, and they have the same slope. But they could have different X and Y intercepts. And I say could, but typically, they should. But what really happens is, first I'll come back to that point. So if I have these two lines that are parallel, they might look something like this. So remember, they're going in the same direction. This is my L1. And they never touch. So the way I drew these look like they might touch somewhere out in space, but if you see these lines that are common to two lines going in the same direction, that means they're parallel. So they're supposed to be parallel. They'll never touch, but their slopes are the same. right? Their slopes are the same. But they intersect the x and y axes at different points. This one's cutting the x and y axis in the origin, so it's hitting both at the same time. This one's cutting the x and y axis at different times. What I mean by they could have different x and y intercepts is exactly this, but what if you have a situation where you have a line like this, and then for some reason we have another line that sits on top of it. These have all points in common. Every single point that's on L1 is on L okay, L2. So I could have named them differently, but so let's call it, this is L3 and this is L4. Okay, so every single point that's on L3 is on L4 and vice versa. They're still parallel. They have the exact same slope. They have the exact same direction. In this case, they have the same y-intercepts. But in general, we're looking at more of this type of situation. Okay, so those are parallel lines. The key takeaway here is the value that you're going to take from the parallel lines to solve an equation is pretty much this bit. Okay, these might be useful, something to consider, but the same slope is the key when it comes to parallel lines. Okay, so that's it for parallel lines. Now let's look at the other thing, which is perpendicular lines. Okay, so if two lines are perpendicular, then we know that they meet at a 90-degree angle. So I'm just going to draw the line. We've already seen an example of this. So we have these two lines, L1 and L2. And we know that they meet at a 90-degree angle. So these are sitting in the Cartesian space. We'll put it poorly. Yeah, they're sitting in this space. Okay. Okay. So what do we know about perpendicular lines? Or what can we deduce? One, they intersect at a 90-degree angle. We know that, but their slopes, this is the key part, are negative reciprocals of each other. What do I mean by negative reciprocal? Well, a reciprocal, if I have 1 over 4, then the reciprocal of 1 over 4, I'm just going to flip 1 over 4 and I get 4 over 1. Okay? The negative reciprocal is now I just make the reciprocal negative. So the negative reciprocal is negative 4 over 1. Okay? So the negative reciprocal is that you flip it and then make it negative. And that's the relationship between the slopes. The other thing is that they could share the same y-intercept. That's just a situation where they meet on the y-axis. Right? Right here. 90 degrees right here. They could have the same y-intercept. Okay? Which also means that they could have the same x-intercept. They couldn't meet right here. Right? They could meet right there. Those two lines could meet right there. But I think it's going to be one or the other. Unless they sit in the origin, they could meet in the origin, which is also very possible that they crisscross in the origin. right? In which case, then they share the same y-intercept, they share the same x-intercept, they have negative reciprocal slopes. Okay, so those are mainly the two things that we will take away from this part. Okay, so now that we've done that, I think the best thing to do at this point is to jump into some examples. And this is a good cross section of the examples that you're most likely going to come across in your studies. So let's see. First example. Find the equation of a line that has slope of -2 and y-intercept of -4. So given the information I have the slope of -2 and the y-intercept of -4. Ideally, this is a slope intercept equation. So I just, because they're giving me that m is equal to -2 and b is equal to -4. So I'm not going to stress myself. It's obvious what I should do. I'm going to put this in slope intercept form. So this becomes y equals m is 2, so it's -2 x, and then plus -4, which is just -4. Okay, don't forget that you can't just write y equals -2. You can't, like, don't do this. Don't do y equals -2 -4. That's -6. Yes, this is an equation of a line, but it's not this equation. It's not this equation of a line. This is some other equation of a line. We don't want this. This is what we want. Okay? So they gave us the slope, they gave us the y-intercept, so just use y equals mx plus b and solve it. Example number 2. Find the equation of a line with slope of 2 and passes through the point A at coordinates 4 and 1. Okay, so they've kindly given me the slope, so I know that m is 2, and they've given me a point, 4 and 1. So I have a point, x and y equals 4 and 1. The best option here is to use point slope because we have a point and a slope. Pretty straightforward. So let's do that. So remember the formula was y minus y1 equals m times x minus x1. So I'm going to plug my values in. So just remember that these have to remain. These two that I'm underlining, they have to remain. I sub the point for the y1 and the x1. That's where I put the point. So this becomes y. So it's y1 is -1, right? Y1 is -1. It's right here. And x1 is right here. So, and then m is 2. So keep this thing consistent. M, which is 2, and then x minus 4. And then I use my algebra, so I have y minus 1 equals 2 times x, and then 2 times minus 4, so 2 times x, and then minus 8. And then I need y by itself, so I have 2x minus 8 plus 1, and this is equal to 2x minus 7. So that's my equation. And I'm going to leave it in slope-intercept form unless the question says change it. All right, next example. Find the equation of the line that passes through D, so some point D, 2 and 1, and some point F, 6 and 2. Okay, so we're given 2 points. So this means that we need to find the slope. So if you only have points, start by find the slope. Okay, so remember, slope is equal to y2 minus y1 over x2 minus x1. So I'm going to quickly label these. So I'm going to go x1, y1, x2, y2, so I don't mess this up. And then I'm going to plug my values in. So y2 is 2, y1 is 1, x2 is 6, and x1 is 2. So I end up with 1 over 4. Okay, so now what do we have? If we go back to the previous example, we have a couple points here, and we have the slope. So now we use point slope equation. All right, so let's do that. So we have y minus y1 equals m times x minus x1. So just pick a point. Both of these, we already used these 2 points to find the slope. So that means they're both on the line. So now I could just pick any one of these 2 points to work with. So pick any point, and I would say pick the easiest one that you think is the one that's easiest to work with. So I'm already going to grab 2 and 1 because it's smaller. It should be easier to manage. So it's going to be y minus y1, which is 1. M, from our calculation, is 1 over 4. X minus 2. Okay, so I have y minus 1 equals 1 over 4x. 1 over 4 times x is 1 over 4x. And then 1 over 4 times minus 2 is going to be minus 2 over 4, which is minus 1/2. Okay, so if you're not comfortable with that, we have videos on fractions. Check those out. So it's simply just 104 times negative 2. And you so pretend there's a 1 here. You multiply the top by the top, bottom by the bottom. So you end up with negative 2 over 4. And you reduce that, and you end up with 1 over 2. So if you're not comfortable with that, we have some videos on fractions, how to raise to higher terms and reduce to lower terms. Okay, so now I have y is equal to 1/4 x minus 1/2 plus 1. And if I have 1 and I take away a half, I have a half left. So if I have negative half and I add a whole to it, I have a half. So my final equation is y is equal to 1/4 x plus 1/2. Okay. And we'll leave it there. Unless the question says put it in general form, then we have to do a bit of manipulation to get it in general form. But we'll leave it there. Okay, another question. Find the equation of the line that is parallel to y equals 2/3 x plus 1 and crosses the y-axis at 0, -3. Okay, so it's parallel. Ooh. So it's parallel to this. What do I do when it's parallel? Okay, I just blocked out the whole question. So what do I do when it's parallel? So remember, if it's parallel, same slope. So based on that, m is going to be 2/3. Okay, and then we have a point, and it says that it crosses the y-axis at 0, 3. Well, if it crosses the y-axis at 0, 3, or 0, -3, sorry, this is the y-intercept. And the y-intercept has x as 0 as its x value always, and then the other value is b. So that means b is -3. So my equation is given to me. So this becomes y equals, so if I need to put it in mx plus b form, it's going to be y is equal to 2/3 x, don't forget the x, minus 3, because b is -3. Nice. Okay. Next question. So find the equation of the line that is perpendicular to y equals 1/3 x minus 1 and passes through the point 4 and 2. Okay, so what do we know? We know that it's perpendicular to this. Okay, so let's grab that. So if it's perpendicular, then that means we're interested in the negative reciprocal slope. So m is going to be -3/1 because we have 1/3 and I want the negative reciprocal slope, so it becomes 3/1 and then I want the negative. All right, so I have that, and we could write that as -3. And then now I have a point. So again, because I have a point, I'm going to resort to my slope-intercept form. So I have y minus, not my slope-intercept, my point slope. So I have y minus y1 equals m times x minus x1. So y1, x1. So y minus 2 is equal to -3 times x minus 4. So y minus 2 is equal to -3x plus 12. And y is equal to -3x plus 12 minus 2. So y is equal to -3x plus 10. And there we go. That is my equation. Next example, find the equation of the line that intersects the x-axis at 4, 0 and intersects the y-axis at 0, 4. Okay, so we have 2 points. All right. So there's the way that I would do this. I'd first find the slope because we're not given any information about the slope. So we're gonna first find the slope. Whenever you get 2 points, find the slope because we don't have any information about the slope. So m is equal to y2 minus y1 over x2 minus x1. I'm going to go ahead and label these. So I want this to be x2, y2, and then it's going to be x1, y1. So let's solve that. Y2 is 4, y1 is 0, x2 is 0, y1 is 4. So I have 4 over negative 4, which is equal to negative 1. It's going to be negative 1. But here's the thing. I don't need to use, I could use point slope form, but I don't need to use it because I'm told that this thing crosses the y-axis at 0, 4. So 0, 4, this is the y-intercept, which means that b is equal to 4. So my equation is done. So my equation becomes, if I put it in slope-intercept form, y equals negative 1x, or negative x, we don't normally write the 1, plus 4. And that's the equation. Okay. Find the equation of the line where the slope is 0 and passes through the point 0, 6. Okay, so we have everything that we need. We know that the slope is 0 and it passes through the point 0, 6. So m is equal to 0. And point 0, 6, this 0, 6 looks like 0b, which we know is the y-intercept. So from that, b is equal to 6. So if I write this out fully in y equals mx plus b form, I'm going to end up with y is equal to mx plus b, which I'm going to have y is equal to 0x plus 6. But anything times 0, it's just 0. So I don't need the 0x there. It's not telling me anything. So my final answer is y is equal to 6. And this is an equation. If you remember, this is just a line that is parallel to the x-axis. 1, 2, 3, 4, 5, 6. It's parallel to the x-axis, and it just runs horizontally. This is y is equal to 6. That's the equation, and that's the line. So it's okay to have something that looks like that. Okay, and our last example, find the equation of the line where the slope is undefined and passes through the point -3 and 0. Okay, so this one's sort of tricky, but the information we have is there. So most importantly, the slope is undefined. Once the slope is undefined, then we don't have a relationship between x and y. So let me write that down. If m, or the slope, is undefined, there is no relationship between x and y. So that means that we can't have an equation with a y in there. So y will not be in the equation. Essentially, when you have a situation like this, you grab the point, okay, you take the x value and you just say, well, x is equal to -3, and that's the entire equation. And what does it look like on a graph? So x is -3. Oh my goodness. This is x. X is -3, so I'm going to march along. So 1, 2, 3. So this is -1, -2, -3. I'm going to find this point. Okay, x is equal to -3, and I have a vertical line that is parallel to the y-axis. X is equal to -3. And that's it. That's how you solve it. So if it's undefined, it's just x equals whatever the x value is in the coordinate. Okay? And don't forget that this point here is -3, 0. That's it, and thank you very much.